Hello there, we're going to have the class about roots and radicals. I'm going to show you a square root. Nope, just kidding. Now let's imagine that you have in your house, this is your house, and imagine that you have a rascal. And this is your pet rascal that you captured from the wild. And you got to be careful because this rascal, it's going to be all over. He's going to be eating your algebra book. You gotta be careful with that rascal. He eats everything. He's gonna eat your breakfast. He's gonna eat your rug, and your mom is not gonna be happy with this rascal. So what you have to do is build a cage for him. And rascals are known to like 9 square meters in their cages. They need to have a lot of space. So this is gonna be a 9 square meter cage where our rascal is going to be living in. Okay, so it has to be 9 square meters. How do I build it? Where do I start? Well, I gotta know what's going to be the length of each of the sides because, well, I gotta get some material. I can't say, give me 9 square meters to make. No, I gotta give them the length to make my walls of this cage. So the question is, what is the length of the side of the square of 9 square meters? That question can also be translated to this same question. What is the square root of 9? That's what we're actually asking when you say something like this. That's actually what the square root means. And in mathematical terms, we can use this symbology, square root of 9. That little symbol there that we just used, that you've seen many times, is what we call a radical. So now you know what a radical is. Okay? And of course, we know that the square root of 9 is 3. And we can see right here that we have 1, 2, 3, 4, 5, 6, 7, 8. I'm sorry, 9, including this one, gives you 9 square meters where the rascal is going to be living, and the sides, of course, are going to be 3 meters. 3 meters and 3 meters. So how do we get the 9 square meters? Well, when you multiply 3 times 3, that's the area formula. Okay, so that's pretty much the idea of what a square root is. Now I'm going to give you a method to get the square root of pretty much any number. Like, for example, this one, 144. Many of you guys already know the answer to that one, but we're going to do the whole method to get the result so that you can apply to other numbers as well. So what do we do first? We got to do the prime division of 144. So I'm going to use the prime division method. And of course, we got to remember that we got to use the prime factors, which are the prime numbers, which in our case are going to be only limited to these numbers 2, 3, 5, 7, 11, 13, and 17. And you got to remember that prime factors are not odd numbers. I mean, these numbers are odd, but some odd numbers are not prime factors. For example, 9 is an odd number, but it's not here, so it's not prime. Anyways, just a reminder. Okay, what's going to be next? We got to do the prime division. 144, can we divide it by the first prime number that we have here, the first prime factor? Yes, we can divide that by 2. And the result, of course, you guys know it, it's going to be 72. And then we keep on going because this number is a composite number. We can divide it. I'm going to divide that by 2, I guess. Is it divisible by 2? I think it is because it ends with a 2, so that's going to be divisible by 2. Divide it by 2 and you get 36. That's what you have on this side. And then that 36 we also got to divide by 2. The last number gives you a clue if it's divisible by 2. That 6 is divisible by 2, so I can divide it by 2. And we get, of course, 18. Now 18, I'm going to divide that also. I got to move it a little bit because I don't have any more space. I'm going to continue on this side. 18 is divisible by 2, yes, and you get a 9. Now the 9, is it divisible by 2? Nope, not anymore. So I'm going to be dividing by 3 now. And that's what we have right there. 9 is divisible by 3, and you get another 3. Now all of these numbers that you got in the end of our prime division tree, imagine they're like fruits. All the fruits of this tree are going to be the prime factors of 144. So that means that 144 can be placed as 2 times 2 times 2 times 2 times 3 times 3. That is 144. All right, we got to get the square root of this thing. Well, how do we do it? Okay, first of all, we got to divide, or we got to separate the pairs. Okay, so we get these two pairs into a square root. We take these two twos into a square root, and then these two threes into a square root. And we get here 2 times 2 to be 4. 2 times 2 is 4. 3 times 3 is 9. And this is going to be pretty easy to get the square root, right? Because I know perfectly well that the square root of 4 is going to be 2, and the square root of 4 is also 2, and the square root of 9 is 3. So the whole procedure, if you notice here, of course we know the answer. We got to multiply this. 2 times 2 times 3 gives you 12, and that's the square root of 144. The whole procedure is basically just getting the prime factors of the number and then getting them in pairs, and then just selecting one of those numbers. So for example, here we have these two pairs. One of them goes out. We got these two pairs as well. One of them goes out. We got these two pairs. One of them goes out as well. And then you got to multiply them. Let's take another example. Let's say we get the square root of 16. Everyone knows the answer to that one, but I'm going to give you the method for this problem, because now you're going to be able to verify, to prove that this is actually correct. So we're going to get the square root of 16. We got to do the prime division tree, and you know that it's going to be giving us this result. It's going to be 2 times 2 times 2 times 2. And what do we do next after this? Well, again, we got to pair them up. So here's a pair and here's another pair. And of course, that thing, those two pairs, they have a square root. We know that it's going to be square root of 4 and square root of 4. You don't need to do it. You know, of course, that when you have those two numbers, the square root is going to be exactly the same number that you have there. So these two 2's have a square root, and it's going to be just this 2. And then these two pairs of 2's, this pair of 2's is going to get just 1 2 outside. And of course, what's going to be next? You got to multiply that by themselves, and you get a 4, which is what you were expecting. All right, what about another number that maybe is not going to have an even amount of prime factors such as these? Okay, let's see 24. Let's do the prime division thing. And when you do it, you're going to notice that it's going to be 2 times 2 times 2 times 3. Everyone agrees to this? If you don't believe me, we can verify it. For example, 2 times 2 is 4, right? 4 times 2 is 8. 8 times 3 is 24. So this is correct. But if you still don't believe me, you can do it as the prime division tree. All right, so we have 2 times 2 times 2 times 3. We got to look for the pairs, because those are the only numbers that can go outside of the square root in a way. We can see it in that way. Okay, let's see what we get here. We get this pair only. This 2 and this 3 don't form a pair, so that can't get a square root. But these two guys, you can get a square root of the 2 times the 2. So that means that these two guys are 4. Square root of 4 is going to be 2. But these two guys inside the square root have to stay inside because they don't have a pair with which you can get a square root. with them. So they're going to stay inside the square root. What's going to be next? All you have to do is multiply those guys that are inside the square root. This is going to be the result. This is it. You can't do anything else. You can get the square root of 6 through some other methods, but in many university exams of entry, this is going to be the expected result that you should get. So this is a good method to get square roots without using a calculator. So that's going to be it, guys, with the answer for this one. Okay, let's go with something a little bit different. What about square root of x6? How do I get that? What do we do here? So let's remember what square root means. It's two terms or two numbers that when you multiply them give you, in this case, x to the power of 6. So what are those two numbers that when you multiply give you x to the power of 6? Okay, let's see. Of course it's going to be, okay, also something else. They have to be exactly the same because that rascal lives in a square and squares have all the sides to be the same. Alright, so they have to be exactly the same. So in this case we have x6 equals x3 times x3. When you multiply these numbers, remember from the previous classes that all you have to do is just add the exponents. So when you multiply x3 times x3, you add the exponents and you get x to the power of 6. Okay, so that's why the answer is x to the power of 3, because x to the power of 3 times x to the power of 3 gives us x to the power of 6. Alright, so if that doesn't make much sense, let me just remind you from over here. For example, square root of 16 is 4. Why is it 4? Because 4 times 4 is this number, 16. That's the whole point of the square root, getting two numbers that are exactly the same. Then when you multiply them, give you the number that you're looking for. Okay, so what about something a little bit more complicated? What if we have more literals in our square root? X to the power of 18 and y to the power of 20, z to the power of 4. What's going to be the result of this? Well, if you notice the pattern, you see the 3 and the 6. 3 is just the half of 6. All you have to do then is just get the half of each of the numbers. So, of the exponents, only the exponents, not the coefficients. For the coefficients, which is the big numbers, which are the big numbers that we had over here, you gotta do the prime division method. But for exponents, all you have to do is just divide. So that's gonna be the answer. Okay, let's do another one where we have a coefficient and a literal with exponents and another literal with exponents. First of all, I'm going to do the coefficient. I'm going to get the square root of 68. So I got to do the prime division method, and I'm going to start with this. 68 is divisible by 2, and it gives us 34. That's divisible by 2, and it gives us 17. All of these numbers form the prime factors of 68. 68 is the same as 2 times 2 times 17. Okay, we have here a pair. Only that guy is going to get a square root. And that is going to be 2. That's what I have here. And the 17 is going to stay there. Why didn't I continue dividing the 17 over here at this step? Because 17 is a prime number, so I got to stop right there. And the 17 is going to stay inside the division house. X to the power of 14 and y to the power of 12, that's going to be what I'm going to do next. I got to divide them by 2, each of the exponents. So x to the power of 14 goes outside. I got the square root of that, and it's x to the power of 7. And then y to the power of 12, when I get the square root of that, it's going to be y to the power of 6. That is going to be the result of this square root. And we're done with that. Hey, what about fractions, you may be asking me? How do I get the square root of a fraction? What do I do here? Well, it's gonna be pretty easy. All I have to do is just get the square root of the numerator and the square root of 49. And then after that, I gotta get the square root of each of these guys. And I know, of course, that square root of 25 is gonna be 5 because 5 times 5 gives us 25. And square root of 49 is gonna be 7 because 7 times 7 gives us 49. That's it. That's all you have to do when you get square roots of fractions. Hey, how about decimals? How about this 0.09? Well, actually, we don't say 0.09 in the streets. That's what we say. But really, the correct way to read this number, it's going to be square root of 900ths, right? So that 900ths, that means something, and that should ring a bell. That should remind you of something. That should remind you of a fraction. So let me remind you that a decimal like this guy, it's actually a fraction in disguise, which is 9 over 100. 900ths, right? That's why we name this guy 900 because it's 9 over 100. All right, now we have a fraction right here. How do we solve it? What do we do now? You know what? It's the same method as I told you a while ago. It's a fraction, so that means that you have to get the square root of the numerator and the square root of the denominator. And then, well, I just proceed to get those numbers as I did before. Square root of 9 is going to be 3, and square root of 100, it's going to be 10. That's the answer, 3 over 10. But, well, the question was with decimals, so probably it's a good idea to return the answer as a decimal as well. 3 over 10 is going to be 0.3, 0.3, or 3/10. That's the correct way to say it, right? Okay, that's going to be it. You got the answer to that problem. Now let's see something else. Hey, how about cubic roots? Okay, let's imagine that the rascal that we have, he wants to go into the tank of water, your fish tank. He's a rascal. And this fish tank is going to be having a volume of 8 cubic meters. Okay? And the question is going to be, what is the length of one of the sides of, or the edges of this cube? What's going to be the length of the edge of the cube? Okay? Or the sides, I don't know. Okay. Let's remember the formula for a prism. It's going to be volume equals length times width times height. But of course, this is a cube, and a cube has all the sides to be the same. That means that we're looking for three numbers that when you multiply them, give you 8. So when you're asking what is the length of one of the sides of a cube, you're actually asking for what is the cubic root of 8. And of course, those three numbers that when you multiply them and are exactly the same is going to be 2. So you have 2 times 2 times 2 is going to be giving you 8. So that means that the cubic root of 8 is 2. This is the symbology for placing cubic root of 8. We got to use the same radical symbol, but here instead of a 2, well, actually before we didn't place a 2. You could also place a 2 if you want, but we don't do that usually. We just start placing different numbers here starting from the 3. And if you want a cubic root, you put a 3 here. If you want a cubic, not a cubic root, but a root to the power of 4 or something like that, you put instead of a 3, put a 4 and so on. Okay, and how do we get this result? How does it change? How does things change for us when we're looking for cubic roots? Well, here it is, cubic root of 8. Let's remember, we're going to do the same procedure as before. We got to use the prime division method for 8, and it gives us 2 times 2 times 2, of course. But now, instead of looking for pairs like we did before for the square root, what we do now is look for triads, sorry. Triplets, no, not triplets, triads. We're going to look for groups of 3 or triads, whatever you want to call that, okay? So here we do have a triad of 2. Here it is, so that means basically that those 3 guys can go outside of the square root because they have a cubic root, outside of the cubic root, okay? And that's going to be 2. Now, how about something a little bit more juicy, more complicated? What's going to be the answer? What's going to be the answer here? It's pretty much the same as before. What you have to do is, well, get the prime division of 216. You're going to get all the prime factors. You know what to do there. The factor tree. And it gives us this 2 times 2 times 2 times 3 times 3 times 3. What do we do next? Well, we gotta find not pairs of 2s or 3s. What we have to do now is get pairs, or no, not pairs. We're gonna get triads or groups of 3, and those are gonna be the guys that get a cubic root. And indeed, we have these pairs, these groups of 3s, and this group of 3 has a cubic root, which is going to be 2, and this group of 3s has a cubic root, and it's going to be 3. Now what's going to be next? We're going to multiply that, and we get a 6. Alright, so that's pretty much it, guys. I hope everything was clear. If not, you can ask me or send me an email or in the comment section, wherever. That's it, guys. I hope you have a great day. I'll be expecting your questions if you have any. All right, well, you have a great day. I'll see you later.